In this video I'm going to talk to you about the unit circle. Now it's called a unit circle because the radius is 1 unit. So let's place this unit circle on a Cartesian plane of x and y. I'm going to try my best. Now clearly radius of 1, I've given it centre 0, 0. Okay, so its centre is the origin. Now if it's got a radius of 1, let's look at what's happening in the y direction and the x direction. So what I'm going to do is form a right angled triangle where this is our y direction and up to here is our x direction. And I'm going to have a look at the effects of this angle here. You may remember from looking at radians to degrees and degrees to radians, if you've studied that the unit circle also can be applied to either degrees or radians. So if we're talking about degrees, we start at 0 degrees and we move anti-clockwise up here. Now this is a right angle between this in this quadrant here, so of course we have 90 degrees up here. If we keep going round, we have 180 degrees and we continue to move round 270 degrees and so on. And the good thing about the unit circle is it continues to go around and round in an anti-clockwise direction. This produces one of the 3 trigonometric ratios. Either produces the sine curve, the cosine curve or the tangent curve, which will be studied in a further video. So let's have a look at these trig ratios within this x and y direction. If I look at a right angled triangle and we use, let's first of all use sine. Start with sine. We know that sine of theta is opposite over hypotenuse from our trigonometry days. Let's have a look at the unit circle. The opposite is y, the hypotenuse is 1. So we can say that sine theta, is just y. Sorry, for a moment I thought I'd wrote something else. So sine theta is y. In other words, that means on the unit circle that sine of a particular angle is the y coordinate on the unit circle. Let's have a look at the other trig ratios. Let's look at cos theta. Well, cos theta is adjacent over hypotenuse. Well, in our days, we sub that in. We've got the adjacent is x, the hypotenuse is 1, so therefore cos theta is to do with the x coordinate of the unit circle. And let's have a look at tan. Well, tan theta is opposite over adjacent. Opposite is y, adjacent is x, which is y over x. Now if we have a look at what y is and what x is, we can say that tan theta is also equivalent to sine theta over cos theta. And this is actually one of the trigonometric identities which you may study later on. But it's really useful to know that tan theta is sine theta over cos theta. All right, I'm going to clear some space. Now what I'm going to do, I've just summarised that information over on the right hand side. What I'm going to do is I'm going to look at something called these boundary angles. That means, well, what happens if we wanted to work out sine of some of these angles that actually sit on the coordinate axes? So if we look at 0 degrees, could be radians or degrees, then what we do is we look at, well, what's sine of 0, what's cos of 0, what's tan of 0. And by looking at the y or the x coordinate on the unit circle, we can work out those values. So at each of the unit circle coordinates, let's just write those on, because remember the unit circle has a radius of 1. This coordinate at this particular point is 1, 0. This coordinate here is 0, 1. This coordinate here is minus 1, 0. And this coordinate down here is 0, minus 1. So we have the coordinates at what I call the boundaries. Now, let's have a look at what sine of 0 is. Sine of 0, here's 0 here. Sine of 0, that means the unit circle has gone 0 degrees. We look at the y coordinate. So sine of 0 is the y coordinate, which is 0. And you can obviously check all these on the calculator. Let's look at cos of 0. Well, cos of an angle is to do with the x coordinate. And at 0 degrees, the x coordinate is 1. So cos of 0 equals 1. And we can look at tan of 0. Tan of 0, which is our y coordinate over our x coordinate. Well, y is 0, x is 1, and of course 0 divided by 1 is 0. So tan of 0 is 0. Let's have a look at some other ones. Now, don't forget the unit circle can also be in radians as well. And if we're looking at the unit circle in radians, as we go around anti-clockwise, we've got pi upon 2 degree radians. We've got pi radians, and we've got 3 pi upon 2 radians. So let's pick another boundary angle. Let's go for pi. Okay, let's have a look at pi. So if I wanted to work out sine of pi, sine pi, sine is to do with the y coordinate. So we look at pi degrees all the way around on the unit circle, which takes us to this coordinate here on the unit circle. And the y coordinate is 0. So sine pi is 0. Let's look at cos pi. Cos pi, all the way around, looking at the x coordinate, is -1. So -1 is the value of cos pi. And similarly, we could do tan of pi. Tan pi is the y divided by the x. So 0 divided by -1 is 0. And I could look at any of these boundary points to figure out any of these angles. So 90 degrees I could work out, or pi upon 2, 180 I've just done. I could do 3 pi upon 2 using this coordinate here for the x coordinate and the y coordinate. And obviously what we'll find is when we do try and do 0 divided by something, so if I wanted tan of 270 degrees, I would get -1 divided by 0. We can't divide by 0, so we would say that would be undefined. Similarly up here, if I needed to divide by 0, because of course we're dividing by the x coordinate, apologies, I think I said the y a moment ago, we can see that we're going to be dividing by 0, and we can't divide by 0, so that tan of pi upon 2 would be undefined as well. Alright, that's pretty much mostly what you need to know about boundary angles and the basics of the unit circle. However, there's a lot more to learn about the unit circle. I will show you that in another video.